Okay, this is lesson 2.2 and 2.3. It's multiplying polynomials and factoring polynomials. So I'm going to do two examples of how to multiply a polynomial, and we kind of did it in the last video. That's why I've combined these two lessons. But what I've done here is I've done two fairly basic ones, and I'm going to get you to try two that are a little bit harder. So I've included some notes here about how to multiply. So we're always using the distributive property to expand. Multiplication, order doesn't matter, so you can change the order if you're multiplying more than one thing to kind of suit your needs. And make sure at the very end, after you've expanded, you collect your like terms and then arrange your terms in alphabetical order and by descending power. So that means if you have multiple variable letters, generally the order for them would be alphabetical. And then if you have terms that have varying exponents, you put the highest exponent first and then work your way down. So let's try a couple examples. We've got three functions here. We've got f of x, g of x, and h of x. First example is we got f of x times h of x. That dot's used to show multiplication so we don't get it confused with the letter x. So let's try it here. F of x is x minus 2, and just like when we were adding or subtracting, I'm going to replace it in a bracket, times h of x, which has three terms. 2x squared plus 3x minus 5. And now this is a little bit more complicated than your traditional FOIL because it's not a 2 by 2. It's 2 terms by 3 terms. Kind of works the same way though. Every term in the first bracket needs to multiply every term in the second bracket. So let's start with our x and multiply it by every term in the bracket. So we got x times 2x squared will be 2x cubed. Remember, you're adding the exponents, multiplying the coefficients. X times 3x will become 3x squared, and x times negative 5 will become negative 5x. That's the first part of our expanding. The second part is multiplying everything in the second bracket by negative 2. Negative 2 times 2x squared would be negative 4x squared. Negative 2 times 3x is negative 6x. Negative 2 times negative 5 is positive 10. Now we have a polynomial expression with some like terms that we can collect and simplify. There's no other cube terms, so we're going to write that one down first because it's our highest exponent. There's two squared terms, so we're going to add them. And we get negative x squared, 3 minus 4. There's two x terms, negative 5x, negative 6x. Together that makes negative 11x. And there's only one constant term, 10. And there's our final expression. What I'm going to get you to try is f of x times g of x times h of x. So you can pause the video, try it now, or you can try it at the end of the video, check your answer. Actually, I changed my mind. We're going to do this example, and we'll leave the bottom two. So let's try it. F of x times g of x times h of x. F of x is the x minus 2. G of x is the x plus 5, and h of x is the 2x squared plus 3x minus 5. Now you got a couple options here. Multiplying is associative, so you can change the order. We've already done f of x times h of x. And if you notice that you've done something like this in your homework or on a test or something, you already know the answer to this multiplication. And since the order doesn't matter, you could change the order here and say f of x times h of x, then times g of x, and just use your answer from the first part. And then at the very end, all you have to do is multiply your answer by g of x. And that would save you some work. Let's pretend we didn't notice that. And let's just expand it out and see where we end up. We've got a 2 by 2. X minus 2 times x plus 5. Let's multiply that first. And that's just regular FOIL. So x times x is x squared. X times 5 is 5x. Negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. And our second bracket will just leave the same for this step. Now we should collect our like terms in our first bracket, so our expanding is a little bit simpler. If you forgot to do that and you expanded it, you would still end up with the same answer if you expand it correctly. But this is going to save us 3 multiplication steps if we remember to collect like terms first. And what we end up with here is a 3 by 3. 3 terms times 3 terms. So we got to multiply every term in the first bracket by every term in the second bracket. So let's start with x squared. X squared times 2x squared would be 2x4. X squared times 3x, 3x cubed. X squared times negative 5, negative 5x squared. Now move on to the 3x. 3x times 2x squared, 6x cubed. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Last term's negative 10. Negative 10 times 2x squared, negative 20x squared. Negative 10 times 3x is negative 30x. Negative 10 times negative 5 is positive 50. There we go. We got a lot of terms there. Now we got to go through them and collect all of our like terms. There's only one term with the exponent 4, so we're going to start with 2x to the exponent 4. Now we're going to go through and look for all of our cubed terms. Well, we got 3, 6, and that's it. 3 plus 6 is 9, so we got 9x cubed. Now we're going to look for our squared terms. We got 5, 9, 20. 3 terms. So negative 5 plus 9 is negative 4. Minus 20 is negative 24. Nope, that's wrong. Let's do that again. Negative 5 plus 9 is positive 4. Minus 20 is negative 16. And x terms, we got negative 15x, negative 30x, negative 45x. And only one constant term, it's 50. All right, there's some big expanding. And we end up with a polynomial expression. So the ones I'm going to get you to try to do are quite complicated. Well, the first one not so much, but the second one. The first one is just one polynomial squared. So to do this one, we would just write the polynomial twice and FOIL it out. So it'd be very similar to this step. And then this one is much more complicated. It's negative 2 times h of x times g of x, and then add your answer to f of x times g of x. See if you can do that one and end up with the answer. You can try it now, or you can wait and try it after the video. Not going to change my mind this time. Factoring polynomials. Factoring is something that we learned last year. We're going to spend another day on this after today's lesson. But I wanted to review 3 types of factoring. And we'll spend a lot more time in class doing other types of factoring. And then we'll do an application question where we do a 4th type. But here are our 3 types. And to aid in factoring, what I've done is I've come up with a factoring flowchart, which is not here, but here. And it's on the next page. And basically where you start the flowchart is right here. And you ask yourself these questions and kind of flow through it. The first question you should always ask is there a greatest common factor? And if the answer is yes, you should factor it out first. Once you've thought about common factor, the next question is it a binomial? If it is a binomial, the type of factoring that we can do aside from common factoring, which we did first, is factor a difference of squares. If it is a difference of squares, we're going to use factoring of a difference of squares patterning. If it's not a difference of squares, it could be something called a sum or difference of cubes, but we aren't going to use much of that this year. So essentially, if it's a difference of squares, that's the only type of 2-term factoring we're going to do. If it's not 2 terms, then hopefully it's 3 terms. If it is 3 terms, look to see if you can factor it by grouping, and if you can, go for it. If you can't, maybe it's a perfect square trinomial. If it is a perfect square trinomial, there's factoring for that. If it's not, then we're just going to factor it like a regular trinomial, where we're looking for 2 numbers that multiply to a times c and add to b. And if it's not a general trinomial, then we can't do any factoring. Anytime you see is it prime, that's the end. If it's prime, that means it can't be factored. So here's a flowchart to help your thinking, but we'll work through this flowchart without actually referencing it when we do our 3 examples here. So let's take a look. First thing on that flowchart was to look for a common factor. So we ask ourselves first, is there a common factor? And the answer is, yes, there is. 2 is common. So we start by dividing all the terms by 2 and writing the 2 in front, and that's common factoring. Once we've common factored, Excuse me. Once we've common factored, then we're looking for products and sums. We're looking for numbers that multiply to 16 and add to -10, because there is no a value. Well, there is, but it's 1. If there was an a value bigger than 1, then we'd have to do a complex trinomial. Since it's simple, we can just directly look for those numbers and then come up with our two brackets. X will be at the beginning of both brackets, and we're looking for numbers that multiply to 16 and add to -10. And the two numbers that do that are -8 and -2. And this would be our final factored form. Now, if there's a coefficient on x squared and we can't common factor it, like in this example, it's a complex trinomial. And to factor a complex trinomial, we look for numbers that multiply to a times c, which is 15, and add to 8. And the numbers that multiply to 15 and add to 8 are 3 and 5. So what we do is we break up that middle term into 3x and 5x. And then we factor by grouping. Group the first two, and we can common factor 3x out, and we're left with x plus 1. Group the second two, we can common factor 5, and we're left with x plus 1. Now the bracket x plus 1 is common. That becomes our first factor. And what's left over is 3x plus 5, our second factor. So common factoring, simple trinomial factoring, complex trinomial factoring. But the second question in that flowchart was, is there two terms? And if there is two terms, we have to ask ourselves, is it a difference of squares? And our third example is a difference of squares. The reason you can tell is if you can square root both terms and there's a minus sign in the middle. So can you square root 4x squared? The answer is yes. You get 2x. Square root of 4 is 2, square root of x squared is x. Can you square root 25? Yes, it's 5. And those two answers become very important because factored form for a difference of squares is two brackets, one with a plus, one with a minus, and the beginning term of both brackets is the square root of 4x, which is 2x. Sorry, square root of 4x. Sorry, the square root of 4x squared is 2x. That becomes the first term in both of our factors. The second term in both of our factors is 5. One time plus, one time minus. And that's factoring a difference of squares. So the flowchart is there to help you do some factoring. So you can reference it when you're starting factoring, but hopefully by the end of it you'll find just following 3 questions of common factor first, is it 2 terms or 3 terms, is going to help you do most of your factoring. Now, what if it's 4 terms? This is our last example. If it's 4 terms, you hope to be able to factor by grouping. So here's my 4-term polynomial. And this is an application type question. Sheila wants to paint the front of a rectangular door. The front of the door has an area represented by this function. Determine the expression for the measure of length and width of the door. Well, if it's a rectangle, we know that area is length times width. So something times something. So if we can factor this into an expression where it's something times something, or factored form, then the first factor could be our length and the second factor could be our width. So let's try factoring. Area equals 2n cubed minus 12n squared plus 3n minus 18. Now when there's 4 terms or more than 3 terms, we have to try grouping. So let's just group it the way it's set up. I'm going to group the first 2 and look for something common. What's common is 2n squared. We take n with the biggest exponent we can, in this case it's squared. And what that leaves us with is an n minus 6. And if we look at our second pair, we can common factor just a 3. And we'd be left with n minus 6. And hey, if you end up with 2 of the same bracket, that means that the grouping and factoring has worked, because now you can common factor the bracket, and you're left with 2n squared plus 3 in the second bracket. And now we have an area expression where it's something times something, so we could say that the first term's the length and the second term's the width. You can change the order, you can say vice versa. It doesn't matter as long as one is one and the other is the other. So our length is going to be our n minus 6, and our width is going to be our 2n squared plus 3. And there we go, factoring to come up with the length and width of a rectangle in an application. That's it for lesson 2.2/2.3. Thanks for watching, and I'll see you next time.